Hi. Today we're going to look at glycolysis, and I'm going to go for a simple version. We're going to opt for a simpler version of glycolysis. Of course, so far you've been working off a diagram that's similar to this one here that shows all 10 chemical reactions, all 10 steps of glycolysis, and what happens at each step. So I'm going to kind of simplify that as much as I can, but I'll refer back to this particular flow chart of glycolysis from time to time in this video. All right, so I'm going to use this here, which it's a real basic model. There's not much animation here at all, if any. So you'll have to bear with the low-tech kind of version of what I'm showing you here. Okay, so essentially in glycolysis, what we're trying to do is break the molecule up, the molecule of glucose, and try to extract a little bit of the energy. So I've got glucose right here, if you follow the cursor, all right? And what happens let's return this back to normal. We've got 6 carbons that make up the glucose. And what happens is an ATP molecule is used to attach a phosphate to the sugar, and another ATP molecule is used to attach another phosphate to the sugar. And if you go back to this diagram right here, this happens at reaction number 1, or step number 1, and it happens at step number 3 right there. So you can see ATP becoming ADP. And then glucose becomes glucose 6-phosphate, and then fructose 6-phosphate becomes fructose 1,6-bisphosphate. It's called 1,6-bisphosphate because it got 2 phosphates. All right. So right now the glucose is primed for splitting and energy extraction. So that's actually what happens next. So I just shift everything around here just to show the splitting. So we split the glucose down the middle, and now we've got 2 molecules that have 3 carbons in it each. And ultimately what we're creating from reactions 4 and 5, which are right here. So there's reaction number 4, which splits the fructose 1,6-bisphosphate to glyceraldehyde 3-phosphate and dihydroxyacetone, and then reaction number 5 converts dihydroxyacetone into another glyceraldehyde 3-phosphate. So what I've got here is 2 molecules of glyceraldehyde 3-phosphate. What happens next is essentially a redox reaction. Electrons go to NAD molecules. You can see I'm kind of demonstrating that right here. At the same time that happens, let's kind of shift this around again, another phosphate gets added to each of those G3P molecules. Okay, so we've extracted some of the energy from the sugar in the form of a redox reaction. We've taken electrons from the sugar and given it to NAD, and these guys are temporary energy forms. NAD are energy carriers that are eventually going to carry that energy from the electrons to the last stage of cellular respiration. All right, and so we can see that. Whoops! If you go back to this flow chart here, we see that in reaction number 6 right there. So we're glyceraldehyde 3-phosphate becomes 1,3-bisphosphoglycerate. So I've got another phosphate. NAD becomes NADH. Okay, so that's redox reaction, a form of energy extraction. Now, in the remaining steps of glycolysis, which are, if you follow the cursor, which are right here, all right, we make some ATP. We invested energy at the beginning, up here in reactions 1 to 3. Now we're getting energy back in reactions 6 to 10, and specifically in reactions here and here, we're getting some ATP back. All right. So what happens is these 3 carbon molecules right here will give up a phosphate back to ADP, and we recreate ATP. And we do that again. We give a phosphate back to these molecules and create ATP. So you can count them up. 1, 2, 3, 4 molecules of ATP are made as a result of those chemical reactions. You can see that here. 1, 2, 3, 4. So what we're doing is investing energy in the form of ATP right here. we split the sugar and get energy back in the form of a redox reaction, and then some production of ATP. So essentially that is what glycolysis is. All right, so if I just do that real quickly again, give my electrons back here. So let's do that real quick so that you can see that again. So we got our 6-carbon molecule. We attach a phosphate on one end, a phosphate on another. That's the investment phase. Then we split the sugar down the middle. We transfer electrons to NAD molecules. That's energy extraction. When that happens, more phosphate gets used. ATP molecules get used. So we get this. And now we do the payoff as well. So those phosphates that are found on these 3-carbon molecules go to ADP molecules like this. We create ATP. We create more ATP. And then we're done glycolysis. And the remaining molecules right here are pyruvates, and they're going to go to the second stage of cellular respiration. So hopefully this made a little bit more sense to you, and hope you enjoyed it.